Good day everyone and welcome to our next lesson. In this video, we will be talking about hazardous wastes, what are their differences with normal municipal solid waste, and how do we characterize and treat our hazardous wastes. Let us start by defining what hazardous wastes are. Well, we have several definitions of hazardous waste, so by the end of our definitions, you would have a general idea of what hazardous wastes are. First, we have a definition from EPA. They say that hazardous wastes are waste that require special precautions in its storage, collection, transportation, treatments, or disposal to prevent damage to persons or property and includes explosive, flammable, volatile, radioactive, toxic, and pathological wastes. You have to take note of the following keywords here, such as explosive, flammable, volatile, radioactive, toxic, and pathological wastes, because those are the most common traits of hazardous waste. If one kind of waste material falls under one of these classifications, then chances are it is classified as a hazardous waste. Other definitions of hazardous waste exist, such as a solid waste or a combination of solid wastes, which, because of the quantity, concentration, or physical, chemical, or infectious characteristics, may cause or significantly contribute to an increase in mortality or an increase in serious irreversible or incapacitating reversible illness. It can also pose a substantial present or potential hazard to human health or the environments when improperly treated, stored, transported, or disposed of or otherwise managed. These definitions give a grim description of hazardous waste, but the precautions that we are taking to manage hazardous waste are worth it because hazardous waste really are detrimental not only to the environment but also to us and the ecosystem. So for us to better understand the nature of hazardous waste, let us define some of its characteristics. First characteristic is toxicity. Is it poisonous? Is it acutely poisonous, or does it have carcinogenic, teratogenic, or mutagenic effect on humans and other organisms? Acute toxicity means that it is lethal or very toxic at high exposure concentrations. Carcinogenic means that it can induce cancer. Teratogenic means that it can harm an unborn child. Mutagenic means that it can alter genetic material and other generally toxic effects. Another characteristic of hazardous waste include ignitability. Ignitability means that it can ignite under certain conditions such as friction-sensitive substances such as solvents, ignition triggered by static electricity. By the way, an example of a toxic hazardous waste are spent solvents used for manufacturing. Some spent solvents are also ignitable. So that means that there are certain solvents classified as hazardous waste that are both toxic and ignitable. By the way, out of all these characteristics, some hazardous waste can have more than one, while other hazardous waste only conform to one of these characteristics. Here we further discuss the difference between acute and chronic toxicity. For acute toxicity, the effects of one massive dose of the toxic substance is lethal. That means that if you ingest a big dose or concentration of a substance that possesses acute toxicity, that could be lethal to your system. In contrast, we have chronic toxicity, wherein the effects of exposure to small doses over longer periods of time is more relevant. Substances that exhibit chronic toxicity may not be harmful at large concentrations, but smaller exposures spread across a longer period of time could be more lethal if the substance possesses chronic toxicity. Okay? So those are the two types of toxicity in hazardous wastes. Other characteristics of hazardous waste include corrosivity, meaning it is capable of corroding metals by chemical reaction, can cause severe damage to exposed tissue. Now, corrosivity is one subset of reactivity because if a substance is corrosive, then definitely it is reactive. But the term reactivity is reserved for a more general description of the reactive nature of the hazardous waste. So when we say reactivity, it is unstable under normal conditions and readily undergo violent chemical reactions. It reacts violently with water and it can also create spontaneous explosive mixtures like toxic gases, vapors, and fumes and are capable of detonating. An example of a corrosive hazardous waste is spent acid waste such as spent sulfuric acid. While spent sulfuric acid can also fall under the category of reactivity, it most certainly falls under corrosivity. Okay, so reactivity is a broader term and corrosivity is just a subset of reactivity. We have here a list of the most common hazardous waste that we might be able to encounter. First, we have spent halogenated solvents used for degreasing, such as trichloroethylene and methylene chloride. These are used in some industrial and manufacturing processes, such as in the manufacture of semiconductors. Spent non-halogenated solvents such as xylene, acetone, ethyl benzene, and ethyl ether. These are normally found in manufacturing industries. Wastewater treatment sludges from electroplating operations. This is different from the sludge of a normal wastewater treatment plant operation because this electroplating sludge contains large amounts of heavy metals. As such, it is considered as a hazardous waste. Dewatered air pollution control scrubber sludges from coke ovens and blast furnaces. These are considered hazardous waste because of the potential presence of heavy metals as well. Sludge generated during the production of various chromium compounds. This is applicable in the processing of leather. And API separator sludges from petroleum refineries because again, this might contain toxic organic compounds as well as some heavy metals. Now, not all hazardous waste can be found in an industrial or in a commercial setting. Sometimes, we can also find hazardous waste lying in our household. I have here a list of several products that we use and potentially what kind of hazardous waste can they generate. First, we have plastics. Plastics can generate organic chlorine compounds, which are considered as hazardous waste when they are forced to decompose. For example, when you burn them, the pungent smell that you generate from burning plastics or rubbers are indications of gaseous hazardous waste that are being generated. Pesticides may contain organic chlorine compounds and organic phosphate compounds, which are very toxic to us. Medicines may contain organic solvents and residues or heavy metals. Paints may contain heavy metals, pigments, solvents, and organic residues, especially for old versions of white paint, because the early versions of white paint used to contain lead, so that's a heavy metal. Oil, gasoline, and other petroleum products can contain oils, phenols, and other organic compounds, heavy metals, ammonia salts, acids, and caustics. Metals may contain heavy metals, fluorides, cyanides, and alkaline cleaners, solvents, pigments, abrasives, plating salts, oils, and phenols. Leather may contain heavy metals and organic solvents. Those are being used to tan the leather or treat the leather. And textiles, such as the ones we use for our clothing, may contain heavy metals, dyes, organic chlorine compounds, and solvents. All of these hazardous wastes are coming from the manufacturing aspect of this consumer product. So some of the products that we are using definitely are contributing to our problem of managing hazardous wastes. Here is a list of some exempted hazardous waste. We have domestic sewage and irrigation return flows. Irrigation return flows may contain excess pesticides, insecticides, and fertilizers, which should make it as a hazardous waste, but normally these are in very dilute levels such that they are no longer considered as hazardous waste. Domestic sewage is also exempted as a hazardous waste since it undergoes its own process, that is the wastewater treatment process. Mine tailings or the wastewater generated during the processing of ores in mining are exempted from being classified as a hazardous waste, but they are technically a hazardous waste. The only reason why we are saying that they are exempted is because they are covered by a separate law. By the way, in the Philippines, we have Republic Act 6969 or the Hazardous Waste and Nuclear Waste Control Acts of 1990. That Republic Act gives us the framework on how we should handle or treat our hazardous waste. It also provides a classification of hazardous waste, which we have discussed earlier. Animal manures are exempted because they are covered under RA 9003 or the Ecological Solid Waste Management Act. Mining overburden, same as mine tailings. Fly ash and bottom ash. Drilling fluids. Waste from crude oil. Natural gas. Geothermal energy developments, and nuclear and radioactive wastes. This is covered by a separate act. These are the type of wastes that are exempted as stated in RA 6969. So we have garbage from domestic premises and households. This is covered by RA 9003. Industrial and commercial solid waste, which do not contain the prescribed hazardous waste. These are also covered by RA 9003. Materials from building demolition except asbestos. Asbestos is considered as a hazardous waste. So if a building demolition debris does not contain asbestos, then it is simply considered as a solid waste. Septic tank effluent and associated sludge. This is covered by the Clean Water Act. Untreated spoils from mining, quarrying, and excavation works, but not materials in the nature of tailings, commercially treated materials, and mine facility consumables. This all pertain to the waste of mining industries. Under RA 6969, we have here the prescribed classification of hazardous waste. So this is actually a coded classification wherein a certain classification is assigned a unique alphanumerical code. So you can download a copy of RA6969 for you to see this classification. We have plating wastes, acid wastes, alkali wastes, inorganic chemical waste, reactive chemical wastes, paints, lattices, inks, or dyes, organic solvents, textiles, putrescible or organic wastes, containers, immobilized wastes, organic chemicals, miscellaneous wastes, and oil. This classification allows us to easily identify the type of hazardous waste, and that also helps us in planning what will be our treatment process for the hazardous waste. That's because different classifications of hazardous waste would merit a different type of treatment technology. For example, you would not want to mix your acid waste with your alkali waste because there will be chemical reactions happening, and if you mix them, you might be able to form more toxic substances. Okay, so we do not want wastes from different classifications to be mixed together. Also, it is more economical if we separate our hazardous waste for treatment. It is very expensive and very difficult to treat a mixed hazardous waste because that would entail a multi-stage process that would demand more resources, more money, and more energy. Okay? Now, let's talk about how do we treat our hazardous waste or how do we attempt to manage our hazardous waste. According to the implementing rules and regulations of RA 6969, these are the required component of a hazardous waste management plan. Basically, this hazardous waste management plan is required for all establishments that are registered generators of hazardous waste. For hazardous waste, we have three types of entities: the generator, the transporter, and the treater. The generator is the entity that generates the hazardous waste, and the transporter and the treater are the ones who are tasked to transport and treat the hazardous waste. It is very uncommon for an establishment to be a generator, a transporter, and a treater all at the same time. So for generators, you are required to have this hazardous waste management plan, and this involves preparing an inventory, waste minimization, storage and transport, spillage, treatments, and disposal. Preparing an inventory involves the proponents characterizing and quantifying how much hazardous waste is generated and what are the components of the hazardous waste. Okay, that is very important information for both the transporter and the treater so that they can determine what process do they need to perform to treat the hazardous waste. Waste minimization, if you'll remember in our waste management paradigm, the inverted pyramid, waste minimization is at the very top of that pyramid, meaning that it is our number one priority. Waste minimization is especially important for hazardous waste management because it is very expensive to handle and treat a large volume of hazardous waste. So by minimizing the amount of waste being generated, you are also minimizing the amount of resources that you have to place into the treatments and disposal of hazardous waste. Okay? The storage and transfer plan involves you selecting who will be the transporter of the hazardous waste. A spillage plan is a backup plan that will be in effect should there be a spillage of the hazardous waste. Okay? So the spillage plan contains information on what to do if there's a spillage, who do you call first, and what do you do to contain the waste. And finally, treatment and disposal involves you selecting who will treat and dispose of your hazardous waste. These are the most important components of a hazardous waste management plan. Again, let me refresh you of the inverted pyramid for the hazardous waste management hierarchy. So this inverted pyramid is applicable to both solid and hazardous waste. For hazardous waste, there is so much benefit that we can obtain if we practice source reduction or if we practice waste minimization at the very top of the process, because that makes everything below it easier. That means that you have less wastes to recycle, you have less wastes to treat, and you have less wastes for disposal. As I have mentioned earlier, we have three entities in our hazardous waste paradigm. Those are the waste generators, the waste transporters, and the waste treaters or recyclers. The waste generators are paying both the transporters and the treaters in order for them to take care of the hazardous wastes of the generators. Here are the duties and responsibilities of the waste generators. First, and the most important, determine if the waste are hazardous waste. Because the last thing you want as a generator is you sending normal solid waste for hazardous waste treaters to treat. That move is a big waste of resources and a big waste of time. So waste generators need to determine if the waste that they are handling is hazardous or not. Another responsibility is they need to register as a waste generator. There is an online form. There is an online form provided by the EMB, or the Environmental Management Bureau of the Department of Environmental and Natural Resources, that designates waste generators with their separate identification. Okay? So one generator is provided with a unique identification such that should there be any problems, it would be easy to trace who are the generator. They also need to prepare prescribed quarterly report form, which dictates the volume of the hazardous waste that they have sent for treatments and if those wastes have been treated properly. Waste generators are also responsible for the proper storage and labeling of wastes, the guidelines of which are provided in RA 6969 and its implementing rules and regulations. They also need to submit the contingency or emergency plan. This is the spill plan that we have been talking about earlier. Basically, this is what will the company do should there be a chemical spill or should there be an accident or an emergency during the storage, transport, and treatment of the waste. And they also need to conduct personnel training. For the waste transporters, they also need to be registered with the Environmental Management Bureau as an accredited waste transporter. Transporters are also required to have their own fleet of hauling trucks. And those trucks have specifications as to what is the minimum and maximum size, what tools or implements need to be on board, and other specifications. The waste transporter also serves as a bridge between the waste generator and the waste treater. Waste transporters are also required to submit a prescribed manifest form. Basically, this is an online manifest which lets the authorities know at what stage is the hazardous waste now. Finally, we have the treaters and recyclers, or the treatment, storage, and disposal facilities. These are the TSD facilities. These TSD facilities need to secure an environmental compliance certificate, or an ECC. Basically, the ECC is required for all heavy industries. We will be discussing more about ECCs when you reach the Industrial Waste Management course. TSD facilities also need to be registered with the EMB. They must also submit the certificate of treatment to the waste generator such that they will have a document that will attest that this waste has been treated. Okay? And they must also be submitting reports to the EMB periodically to check their performance of treatment. Finally, let's power through some of the available technologies for the treatment of hazardous waste. Now, keep in mind that these treatment strategies will only work for a specific class of hazardous waste. That's why it's important for us to separate and segregate hazardous waste based on their classifications. One of the most common strategies that is being used by industries that are within driving distance with each other is the waste exchange. A waste exchange is possible if one industry is near another industry, wherein the waste of the first industry is usable by the second industry. In this waste exchange scenario, the hazardous waste that is being generated by one entity is used as a raw material of the other entity, thereby greatly reducing the generation of waste and improving not only the profitability but also the sustainability of the process. Another technology for the treatment of hazardous waste is solvent recycling through off-site distillation. This is often used for solvents that are mixed and needs to be separated before they are reused again. By the way, hazardous wastes can also be recycled, such as these solvents. However, it takes a lot of effort in order for us to recycle our hazardous wastes. These are some of the physical, chemical, and biological treatments employed to treat hazardous waste. Let us focus on the destruction of toxins, such as thermal treatments. You are simply heating the hazardous waste. Also, we can employ the immobilization of toxins, wherein the hazardous waste is simply encapsulated in an inert material. We have cementitious or pozzolanic, wherein the waste is enveloped into cement and then that is disposed in a sanitary landfill. You can also envelope the waste in an organic polymer, and you can also enclose your waste in glass through vitrification or glassification. Normally, we use pozzolanic and vitrification for the containment of radioactive waste and other types of special hazardous wastes. Some of the physical processes employed for separation include centrifugation, sedimentation, flotation, and filtration. This is useful when separating small particles from fluids, such as solvents and wastewater. Chemical processes such as oxidation, reduction, and precipitation. Precipitation is mainly used for heavy metals because heavy metals often are insoluble with their sulfides, carbonates, and other insoluble salts. Reduction is normally being employed to convert a very harmful form of the metal to a less harmful form, such as from chromium 6 plus to chromium 3 plus. Chromium 6 plus is a known carcinogen, while chromium 3 plus is relatively harmless. We also have this following technologies for the recovery of heavy metals such as electrowinning, ion exchange, evaporation, and membrane filtration. We also have spent acid regeneration, wherein it has the capability to recycle our spent acid waste. The spent acid waste is treated to generate more of the fresh acid, such as sulfuric acid. For biological processes, we have aerobic biological processes such as aeration. Sometimes we can also employ bioaccumulation or farming such that we can concentrate the hazardous waste using bacteria or fungi or plants such that we can then dispose of the concentrated waste. And finally, we have incineration. Incineration is one of the most common processes employed for the treatments of hazardous waste because it is easy and economical. Incineration is the thermal oxidation of organic matter into CO2, H2O, and inert ash. Now, you can think of incineration as a simple burning of substances, but incineration is actually more of a controlled burning. For incineration, we are normally supplying pure oxygen into the process to enhance the burning process. And modern incinerators nowadays are fitted with pollution control mechanisms that prevent the release of unwanted substances into the air. These are examples of incinerators. You can see that they are just like big furnaces in which the hazardous waste is being conveyed inside, it's mixed with air, and it's being combusted. This is a list of the 7 pollutants that can be generated from incineration that we have to watch out for because they are very toxic. We have dioxins and furans. These are generated when you are burning plastics, mercury, semi-volatile metals or metals that can combine with gases, low volatile metals that are part of the ash, particulate matters that can also be part of the exhaust, hydrochloric acid, and chlorine gas. These are just 7 of the most common pollutants coming out of the flue gas or the exhaust of the incineration process. So we do have to watch out for these substances. Modern incineration processes are equipped with pollution control mechanisms that prevent the release of these harmful substances. Incineration has long been banned in the Philippines because of the negative effects of its effluents. But now that we have effective technology for mitigating the pollution caused by incinerators, don't you think that now is a very good time to reconsider our ban on incineration? We have a very big problem in terms of solid and hazardous waste handling, and the lifting of the ban on incineration, provided that there are safeguards in place to protect human health and the environment, can be a big help in our waste processing industry. So that is just some thoughts for you to ponder on as we end our lesson. This is the end of our lesson on hazardous waste. I hope you have learned something. Thank you for listening, and as always, keep safe.